Virtual Fly is a Spanish company that builds flight simulators, but not for the likes of you and me. At the top of Virtual Fly's range are fully enclosed full motion simulators costing upwards of £50,000. Now if you look at Virtual Fly's earlier promotional material, you'll see a number of third-party yokes in their cockpits, notably PFC. But in 2013 Virtual Fly designed its own yoke to standardise the quality and fit across all of its installations. This was the YOKO, and that's what we're looking at today. So first impressions. Well, it's not flashy. In fact, it's quite plain looking. You know, William Gibson, the original cyberpunk author, said that when people ask him what he writes his novels on, they're usually imagining something that looks like a stealth bomber with the serial numbers filed off. I like to think that if William Gibson has a home flight simulator, he's using something like this to fly it. This has a very functional, industrial feel to it. It doesn't brag. There's nothing extraneous on the front panel, no LEDs, LCD displays, no clocks. And the only real concession to branding is this discrete Virtual Fly logo, which you may or may not see on the video. I think it actually says YOKO on the front of the box as well. I can't see the box at the minute. That's obscured by my panel. The other thing to note is this is made of metal. Just about everything you can see here is metal. I believe that's a cast aluminium handle. It's a stainless steel shaft, obviously. The box is steel. The switches, the paddles are actually obviously plastic switches, but they're mounted, I think, on aluminium inserts. Everything about this is solid and weighty. It's got real inertia to it. It's got a very stiff action, but it's extremely smooth as well. There's no stop-start detectable at all. There's no centre detente. It does centre assertively, but that's just because the balance of the push-pull spring action centres it. There's absolutely no detectable notch when you're passing through the centre. The other thing to note about this that sets it apart from most other yokes out there, it's got a very long stroke. This is 14.4 centimetres, 5 3/4 inches. Rotation wise, we've got about 60 degrees rotation lock to lock. Now I've already mentioned that it's got a very firm action. Not everybody's going to like this. We'll say more about that in a minute, particularly when we talk about mounting the yoke. Probably firmer than you're used to in a desktop yoke. And if you measure the force, it takes 5 kilos to pull it to the back stop, to push it to the forward stop. I haven't measured precisely what the rotational force is, but it's in proportion. It's very quiet in operation as well. One of the reasons for that is it doesn't use metal springs, so there's no clanking or ticking as you might get with coil springs. This actually uses bungee cords to provide the spring action. I haven't opened this box up, but I have seen photographs of the inside, and it's well documented that it uses very strong bungee cords. And I'm pretty sure that this shaft is suspended on ball races as well. So we've got that absolutely super smooth action. As I said earlier, absolutely no detectable sticking with the slightest of movements. You can stop it and start it, and it just glides. Gliding is the best sort of verb I can come up with, really. It's smooth. I think I've overstated that by now. So just on the quality of the build and the fittings, I'm assuming this is a cast aluminium handle, but it's very super smooth. It's probably anodised or painted. It's moulded to the shape of your fingertips on the back side. You've got these little thumb rests on the front side. So just a little bit about the switch gear. Now this is something that's going to divide the target market, I suppose. Remember, this is a professional product. It's not strictly speaking a gaming product. Although it does, one thing I wanted to point out was it does present to Windows as a standard game controller, so you can use it in any software without special drivers. Now Virtual Fly does provide its own software to drive this if you wish, which we'll have a brief look at that in a while. But you don't need to use it. You can use the regular ways of setting this up for your sim. I use FSX, so you can use the FSX controls settings dialog, or you can use FSU IPC to tweak this with more flexibility and precision. But that said, we have very limited switchgear. We've basically got two paddle switches. We've got these are two-way rocker switches. So we've got fore and aft switch on this side, and we've got a left to right switch on this side. The only other buttons we've got are a push switch on the front side of each yoke handle to be operated with your index finger. So just coming back to the build quality and the attention to detail, these two rocker switches, they've got a kind of a dual action to them. Now remember, it's a two-way switch, but when you push it to the left, there's two distinct clicks. I think that first click is a kind of a pre-warning of, you know, if you push this any further it's going to make contact. And you know, that says something to me about the quality of the switchgear that's been incorporated in this. I'm sure these are industrial strength switches which are rated, you know, for probably hundreds of thousands of operations. One of the things that Virtual Fly is very keen to point out in its marketing is that this yoke, although it's designed from the ground up to be used in their simulators, it is actually in operation in real world scenarios. And the scenario that it gives is that one of its customers flies an actual, I think it's an amphibious UAV, that's a drone by another name, from a ground station that Virtual Fly have built using this yoke. So you can imagine, and it's a very large UAV, it's, you know, several tons, so, and probably costs, you know, millions of dollars. You don't want something cheap and nasty that's going to break down while you're up in the air with that thing. You know, this is the real deal, and if we need to emphasise that anymore, most of the target market for Virtual Fly's flight simulators, you know, it's the training market and the certification market. So in other words, people can legitimately train on Virtual Fly's simulators and even log time towards currency requirements and so on. And the desktop aviator market is kind of peripheral to that, which is why this is a high priced product. You know, at the end of the day, this is not a cheap product. This is a $1,000 yoke, 820 euros, I think, something 600 and something pounds. But you get what you pay for. Now I just want to mention a slight downer about the yoke before we move on, and that's about the mounting. There's two options for mounting this. The simplest option is to use the bracket. Now you may be familiar with the Cytec ProFlight yokes, and this system uses exactly the same design for mounting the yoke. That said, it's completely made of steel, whereas Cytec's is made of bendy plastic. The problem is, it's inadequate. This, again, you can't really see this from here, but the box is quite long. It's suspended right at the edge of the table at the front side. This means that the yoke can tip forwards when you're pulling towards you, but more significantly, I think, when you're operating it with one hand, which you do most of the time, it'll move from side to side. Now in my cockpit I have the slight advantage of being able to wedge a bunch of books between the top of the yoke and the underside of the shelf that these monitors are mounted on, so that stops it tipping forwards, but it will actually still move from side to side. You know, I can probably show you that there. I mean, it's moving quite easily, and it does that, you know, I'm trying to do it deliberately there, but it does that accidentally or incidentally if you're vigorously operating the yoke. Now this is no secret, and I'm not the first person to point this out. In fact, if you go to Virtual Fly's web page for the YOKO, the first thing you'll see on that page is Virtual Fly's own promo video for the YOKO, and you can clearly see the yoke body tipping and sliding as they manipulate it. So a bit of a fail there. Now that said, this is a slight downer, but they have provided an alternative. This yoke has 4 screw holes cast into the bottom of it, and they also supply you with these, I don't know what you call these, but screws we'll call them. So you get 4 of these, and these will screw into the bottom of the yoke. So the simplest thing you can do is you can drill 4 holes up through the bottom of your table and screw the yoke down to the table. Then it's not going anywhere. Now the other kind of thing you could do is you could get yourself a big sheet of plywood, say, and screw the yoke to that using, perhaps not using these, but using, say, countersunk screws. Then that would lay flat on the table, and you could use G-clamps at the front and rear to clamp it, or something like that. So that's, you know, that's the proper solution to mounting this yoke. The clamp should be regarded, unless they redesign it, as a temporary and not very satisfactory method. The other thing is, you're very limited in thickness of table. My table is just on the limit. It's 3¼ centimetres, 32.5 rather millimetres, and just slides on there. So again, just something to watch out for. And just coming back to the thing I'm going to keep repeating throughout this review, this is a professional product, and the bracket is in a sense a concession to the home user, but you know, somewhat usable in practice. And while we have this box here, we might as well have a look at what else you get in there. You get a USB cable, connects to the yoke, and you get a memory stick with Virtualfly's own driver software or yoke setup software. So that's something we'll just take a look at in a while. And finally you get a bunch of paperwork. So you get a rather you know, cheaply produced setup manual in Spanish and English that has some I haven't actually read through this, but it's got some pictures of the software set up in there, and then you get this kind of a welcome brochure. It's a warranty statement essentially. And finally you get a couple of stickers. I think these are put on the back window of your car or something like that. So if you want to advertise Virtualfly, there you go. So that's about all we can say without going for a ride. So that's what we're going to do next. I'm going to fly it around. This is going to be strictly stick and rudder stuff. You know, we want to see how the yoke performs. We'll do a little bit of bush flying, try and squeeze it in and out of some tight spaces, and seeing if we can really throw it around. Do a bit of crosswind work so we can check out the independence. This is something I didn't really mention, but we've got completely independent suspension of the aileron and elevator axes. That's certainly how it feels. But we're going to check that out in some crosswind landings. So we'll get set up for that and see you there. Let's go. We're going to need every last inch of this strip, so we're going to just creep around the corner. So we want elevator trim set slightly forward of neutral. That's so we can get the tail up as quickly as we can. And we're ready to go. Standing on the brakes, give me full power. Then we'll go. Creeping around the corner, trying to get the tail up. Speed's just about adequate. Take it off. We've got to creep through the gap in the trees. Having to pull back quite hard to hold the climb, but if we trim it up a bit, we should be good to start that turn now. I'm trying to hold it at 65-70 knots for the climb, holding back in the turn. Trying to keep the nose above the horizon so we're maintaining that climb. So we're just overflying the field now. And if we depart on roughly the runway heading or reciprocal runway heading, what I'll do is I'll set up the HSI so we've got that guide on the way back in. We're at about 2,000 feet. That's a good height for now. Alright, so that's a mile and a half. We're going to do a 180 turn now, more or less, back onto the heading that we've got on the HSI. I'm going to do a steep turn, so we want full power. And then I want to hold the nose just below the horizon. That gives me the level turn. I'm having to hold back very powerfully on the yoke, and I'm also having to finesse the aileron just to prevent that overbanking. Okay, so we're headed back towards the strip now. You can see the strip just off the nose. I'm going to dump the power, slow down, and then we're going to put some flaps out. We're going to put all the flaps out. This is a very short strip. Now as I do that, the nose is going to pitch up, speed's dropping off, so I've got to push pretty hard to counter that. A little bit of nose down trim, then we're just finessing that. We're going to trim it for 60 knots in the descent. I'm just going to weave a bit because we do have to lose a bit of extra height. So we're trimmed for about 60 there. I'm just going to let it slide in for now. We're probably going to have to dump a bit of extra height with a bit of a side slip. Just start that now. So I'm kicking the rudder, dipping the right wing, pushing to maintain the speed. Again, we can be very assertive with this yoke because of those powerful springs. Okay, I'm going to straighten it up now. Okay, a little bit more of a finesse. Going to just slide in over these bushes, watching for the trees. Power off, and we just want to hold it off, hold it off, hold it off. And there we go, stall one, and just before we touch down. And then we want to bring it around, try and miss the fence, which we managed to do. Now if you remember back to what I was saying about the mounting of this yoke, as I was just trying to turn that corner there, I was pulling the yoke right back to keep the tail on the ground. The yoke actually shifted to the right, so you may or may not see that. I can shift it back there. So we're going to slide it in over these bushes. Just as we're coming over the bushes, we're going to kick it round to the left with the rope. We're too high, so I'm going to just dump a bit of extra height here. Okay, now we're too low. I'm going to kick it round to the left just as we come over the bushes. Watch out for these trees as well. And then drop the right wing. Bit of power. Now I'm going to hold it off. Power off. Hold it off. Hold it off. Touching down on the right wheel. Now we need to be on the brakes. Oh, there you go. That wind's helping to slow us down actually. Okay, that wasn't the most stylish landing ever, but we got down in one piece. So I just want to have a very brief look at the YOKO driver software. It's not immediately obvious why you need any driver software. The YOKO presents, as I've said, as a regular Windows game controller, but it does something very simple. There's basically two controls on this, two sliders for the sensitivity of the elevator and the aileron, and essentially what this does is it allows you to tweak the mapping of the mechanical yoke movement onto the movement of the yoke in the aircraft model or the virtual cockpit. I've got the joystick visible on screen there, so hopefully you can see that on the video. And what you should see is the mapping is pretty much linear there. It is actually truncated, it's linear, and then that's full scale deflection in the cockpit, but the yoke's not at full scale deflection. It's about 2/3 of the way. But nevertheless, we've got more or less linear mapping in both axes. If I take the ailerons as an example, if I move this, so the sensitivity slider is on 5, it goes from 0 to 10 and it's on 5 by default. If I move it all the way down to 0, you'll see that the mapping has changed. For large deflections of the yoke, we only get a small movement in the virtual cockpit. Now that's around the central point. If you notice that out towards the extremes, the joystick movement in the cockpit suddenly speeds up. Now this is very, if you're used to using FSU IPC, this is very similar to what the slope function does. If you put a slope with a flat spot in the centre, this is exactly how it behaves, and it allows you greater precision around the centre effectively. Conversely, if I go to the other end of the scale and then move the yoke, you see that around the central point it's got a hair trigger sensitivity. We get huge deflection of the virtual yoke for a very small, relatively small deflection of the physical yoke. And then actually we've got full scale deflection when we've barely, got a quarter of the mechanical deflection of the yoke. So again, like FSU IPC, it's like doing the slope with a steep spot in the centre. Another way of thinking about this is a kind of a logarithmic mapping, and if we put the slider on minimum, we've got an exponential mapping. If you want to use this, you need the free version of FSU IPC, which comes on the Virtual Fly memory stick as supplied, and this allows you to change the mapping in ways that you can't do in FSX. And of course, one of the reasons that this is required for this yoke, and this is mentioned very briefly without much explanation in the manual, is because you have that unusually long stroke for the elevator axis. So you do probably suffer if you use the regular FSX setup, because your yoke isn't really going to behave as expected in certainly the pitch axis. The other thing to mention is if you're going to use this driver, you need to go into the FSX options, settings, controls, dialog, and make sure that this checkbox, enable controllers, is unchecked. In fact, you probably don't have to do that. It says you do, but you can probably get away with leaving that checked, going to the YOKO yoke and making sure your aileron and elevator axes are not mapped. The other thing is, this is a very unsophisticated program. You need to run it manually before or after you start FSX. You could probably put that in your xe.xml file to auto run, but Virtual Fly doesn't tell you how to do that. But just to reiterate, if you have the paid for version of FSU IPC, you don't need this at all, so don't worry about it. So there it is, YOKO. It's difficult to find anything more to say about this really. At the end of the day, this is a very simple product designed to control your elevator and aileron surfaces, and with a couple of switches thrown in, and it does that. It does that flawlessly. It does it superbly. The feel is second to none in my experience. Unless you want to go force feedback, this is pretty much as good as it gets. The only reservation is the mounting, which is not really a reservation, as I've pointed out. If you mount it properly, this yoke's not going anywhere. You probably need to screw your chair down as well, given the firmness of the control. Hasn't escaped my notice that this is called YOKO the yoke. Now I don't know if that's a translation artifact from Spanish to English, or if that's a deliberate use of the definite article. YOKO the yoke implies that there is no other, and no need to consider any other. And after trying this out for a few weeks in my cockpit, that's pretty close to the mark.